Okay, YouTube. Once again, Kimberzelik here, and I'm kind of planning my next video. I just finished, well, what did I call that? Something nut, impossible nut. I do like the way that came out, but I'm a little bit ashamed. Is that right? I feel like I should have single point threaded that. So I'm going to work on my single point threading. So I picked out some candidates for high-speed steel. I am in the past have only used this cutter. So I want to give high-speed steel a chance. I am going to be threading some brass, some aluminum, and some 12L14 steel. And I haven't decided on a pitch gauge yet, but I want to experiment with threading upside down and backwards, Joe Pye way, adopted by Blondie Hacks. I feel a little more confident with my half nut lever working much smoother. So in the meantime, I'll get some materials prepped. I need to set up my set up a station behind the lathe to hold my indicators. So there's a bit to do before we start turning any threads. I'll be sure you're involved. No, that's a good picture. Of the gear train. Okay, here are the change gears. Of course, I'm not prepared. My gear blanks, and so we're going to be doing, really not ready, 3/8/16. Is that right? $40 and $40. That doesn't seem right. So we got 4mm wrench and a 5mm wrench. The 5 goes on A and D. The 4 goes on B and C. So it's A, B, same axle, C, and then D. The default factory setting is 20/80/20/80. I stripped out my other 80, so I'm at 65.80. And I feel like I should be doing 13 threads per inch. Half 13, 3/8, 16. Okay, well, I was expecting to do something different. So this is kind of good. We're doing 3/8, 16. Because 3/8, 16 calls for let me double check this. 3/8 375,000. So 3/8, 16 actually calls for 40 in A, and 40 in D. So B and C are there will be nothing. Now, for some reason, the first time I did this, I misunderstood the instructions and thought it said, 40 and 40 and fill in any gears that'll work to fill those two spots. But if it calls for 2 gears, you get it 2 gears. So, you take the screws out of here. All the screws have washers. 2 of these 3 have keys. So I'm going to take this top 20 off. And I'm going to leave the key on the spindle, axle. Take that 20 off of C. Take the 80 off of D. And this should be an 80 here. We'll take the 65. Actually, I'm just going to pull that whole axle off, because nothing goes there. So this is what they call the banjo. There's a nut behind this. You can move this back and forth. There's a nut down here which enables this thing to pivot up and down. So there's something new for both of us here, all of us here. I don't believe I have 2 40-inch gears, 40-teeth gears. 40 and 40. 50. Of course I have them. So, we're talking about 40 on A. Let me push this key down. And we're going to have to take this shim or whatever off down here. Now we have a 40 here. Now we have to get those two to mesh. So we're going to loosen the banjo here, and we're going to loosen it's good if you go the right direction. So loosening that gives you this motion, and loosening that gives you that motion. Now, there is no way to connect those gears, so I'm going to have to bring you back. Okay, I'm not sure if you'll see the segment before this or not, but this is contradicting something that I thought I'd learned. 16 threads per inch calls for a 40-tooth gear in A and a 42-tooth gear in D. Now this actual here is B and C. So it says here, use 40-tooth in position A, 30-tooth in position D, and put any other gear in position B to connect A and D. So that example is for 12 threads, but the same thing is going to apply. So we did the right thing by removing the spacer to get D in closer. And let's just take the 65, which was already there, and get it in position. So I kind of like that, so I'm going to tighten up the bottom of the banjo. And I still have the adjustment here on B and C. I'm going to need this collar on B and C. And I'm going to have to tighten this up. And that is probably too tight of an engagement. Let me power it on here. It actually sounds alright. So let's go ahead. Do I have another collar? I need something here. Keep this gear from coming out this direction. So I think if I take this collar off, put it here where it originally was, and we will put a 20-tooth gear there, which is not only acting as a spacer, it is not engaged. So we should be, or we are, now set up for 16 threads per inch. And just to kind of go over it again, it says I need a 40 gear in A and a 40 gear in D. So this is A, B, C, D. So we're only using this 65 tooth gear to connect A and D. And it says here, put any other gear in position B to connect A and D. So apparently it doesn't matter what gear was used here, which I don't really understand. I mean, if you used an 80 tooth gear there, isn't it going to change the speed? But apparently only A and D matter here. So I'm going to set these gears to the side and set my tools for this operation to the side here. Put my book away. Put my other gears here back in storage. So we should be all set to go. Let's run it one more time. Okay, that sounds good. On my cover here, I basically glued magnets to the inside here. This one's come off and it's not doing anything. But so this is just essentially being held on with one magnet at this stage. My tachometer sensor is screwed into there, and there's a magnet on. There's a magnet on the spindle there. It probably shouldn't be like that. Well, if it's working, it's working. And that sensor reads off that magnet. So let's give it another go here. Okay. Well, we should be set for threading now. So let's go ahead and do what we got to do for the next stage. Okay, I'm down to my last piece here. I tell you, this Morse taper number 2 center drill that I made out of aluminum, actually, it wasn't long enough, so I put this copper pin in it for ejecting. But it sure has come in handy. You know, I reached for the chuck and I realized I don't need it. And we're going to use carbide insert. I got a piece of 12L20 steel. Got a gutter in there that's either at the minor diameter or just below. There's the steel. Here's the aluminum piece. And I thought I was grabbing brass. It turns out I grabbed a piece of copper. But you know what? I'm going to go with it. Copper can be very difficult if it's work hardened, but it can be annealed and softened up and so we'll at least give it a try. So here I have a piece of brass, and it is on 400 thousandths. Well, yeah, 383 anyway. So we need to bring that down to just under 350. We'll measure this and see where we're at. See if we can't hit some numbers there. We can usually do pretty good at hitting numbers. It's usually not so much the machine, it's me doing the math in my head. So, go ahead and walk this back. I'm going to take it all the way back without retracting the tool. And we'll get a measurement here. Okay, there's 350, there's 375, there's 385, 389. So let's call it 390. 389, let's take it down to 350, so that's 40. So let's try 20 thousandths. Okay, I went beyond it. Determine a new zero here. We'll call that 0. Yeah, we'll try 20,000. See how long we can keep this chip. Well, looks like we're going to be able to keep it pretty long. It ain't broke yet. We might enter that into the chip of the week. It's a little warm. A lot warm. Okay, that chip is taller than I am. That was kind of cool. That was 20 thousandths, which is going to take off 40. We're at 375. We were at 375, 385, 380. Hey, we called it 390. So roughly, we should be around 350. It's very hot, and it's much more than 350. 325, 335, 337. Let's check that with the calibers. 340. It's 10 thousandths under. It's awful hot right now too. So, did I overshoot that? I'm not sure what the threads will look like being that. But I'm going to go ahead and put a thread gutter in here, I'm calling it. Make this a little wider. Okay, that's an awful long thread as well. Probably aren't going to thread anything that long. Trying to advance the tool while I'm moving laterally. That's deep enough. Let me shallow this up and widen it a little bit. Okay, that's good. That's not sharp. It's hot. And pull the tailstock back. Okay, there's my 4 materials. We got brass, 12L, 14, copper, and aluminum. Next, we will do the change gears.